Okay, so the last section of chapter 10, 10.8, what we're going to do is pretty significant. Although, for many of you are like thinking, oh, brother, whatever the case might be, but this is very significant stuff we're going to do. The math's actually relatively simple, but the idea is pretty amazing. But what we're going to do is expand our number system. Right now, we're very comfortable with the real numbers. We've done a lot of things with the real numbers. We've graphed, we've solved equations, we've done tons of stuff. And again, real numbers, what we use them for, any number actually, is we use them to quantify our reality. So, how much are my groceries going to cost? How much, is my gas going to cost? How many people have COVID? So all those morbid things or good things, we are constantly trying to quantify our reality. And so that is exactly where the complex numbers came from. So let me give you a quick little history and then I'll cut to the chase. But in mathematics, or actually in the real world, there's a lot of situations where there is a cycle or there's a spin. So if you're into NASCAR or whatever the case might be, right, there's the wind coming off and it kind of circulates around the car, and we call that drafting when you're sitting right behind that. Tornadoes, whatever the case might be, right, they're all cyclic. So they're going around in a very tight circle. Even the electronics that we have to work our phones and to put light in our house, what they do is they take a circuit and they close the circuit. And when we close that circuit, it causes the current to loop around, which causes light and creates the phone to work, creates this computer that you're working on right now. So there's some very real applications. But amazingly, when we try to fit our real number system to mathematically model these real situations that we're seeing and quantify them, what came up consistently in some way or another is this equation. X squared plus 1 is equal to 0. So it might have been, a variety of a number here, but at its core, it was x squared plus 1 equals 0. So we're quantifying our reality. We're seeing these things, right? We can see our electricity. We can, enjoy our electricity. We can see a tornado going around. We can experience the idea of drafting. All these cyclic behaviors. And when we mathematically model it with equations, this keeps coming up. Of course, if I subtract 1 from both sides, I end up with something that in reality is very questionable. As a matter of fact, what we've been saying consistently is that there is no solution. Well, there's no real number to do this. I can't take a real number and square it and get it to be negative. If you think it's 1, 1 times 1 is 1, and if you think it's negative 1, well, negative 1 times negative 1 is still plus 1. So there is not a real number that I can square to get positive 1. So it just does not exist. So that was kind of a quandary for scientists and engineers for quite a while, because again, they're physically seeing something, they're trying to quantify it with our real number system, and it's not working. So what they invented is they created a definition, and then they created this whole world of math around it. What they just basically defined is they defined the letter I to be the square root of negative 1. So there's really not anything to understand of this definition. It is what it is. And then what they did is they built this world of mathematics around it. And and that's basically what we're going to be studying here in 10.8. And like I said, the math itself is not hard once we actually see it. If we were to square both sides, right, then we find that I squared is negative 1. So the solution to this equation is x equals I. And we call this our imaginary number. Okay? And a whole wide world of mathematics was broken up to do that. What we did is we created, based off of this, the complex number system. And all we basically did is take a real number, let's call it A, and we added an imaginary part, let's call it B. A and B are real numbers, right? And basically A is the real part, so it's like having 1 foot in reality, and B is the imaginary part. It's like having 1 foot in imagination land or la la land, where this kind of crazy stuff happens. And before you start really saying, well, this is ridiculous, I think the only thing that I can say is that it's turned out that the math behind this mathematically models these situations fantastically. And that's why we've been able to do so many wonderful things that we've done, because the math supports what we visually see, and so we can make predictions and all that other good stuff. So a complex number, if I want to deal in reality, the complex number would be 5 plus 0i. So that basically equals 5. So what's nice about this complex number is if I let the imaginary part equal 0, we're basically back in reality. I could be purely imaginary. I could have 5i, right? 0 plus 5i. So this basically says we're purely imaginary. This system is a true cycle. As we, if you take an advanced math course, that's what happens in that system. Or we could have a combination of both. So in this situation, I have 5 real parts and 5 imaginary parts. And so I basically have a foot in both realities, one in the real world, one in the imagination world. And so we have this complex number system. Of course, now that we've invented this complex number system, we have to figure out ways to add them and subtract them and multiply them and divide them. Is this new system well defined? And you're going to see that it actually is. All right? And so with this definition, I being the square root of negative 1, we can come back and we can rewrite things that we used to not be able to do in the past. So a couple sections ago, you guys correctly said that the square root of negative 4 is not a real number, and that is still true. However, it is imaginary. I can break this up into 4 times negative 1, which comes up to the square root of 4 times the square root of negative 1. We know the square root of 4 to be 2, and the square root of negative 1 by definition is I. So we now can define the square root of negative 4. It's still not real, right? But it's purely imaginary, all right? So we get this imaginary number of 2i. Cutting to the chase here, we got the square root of negative 25. Well, we know that the square root of 25 is 5, and then if we square root a negative, right, what we get is I. And of course, if you wanted to literally break it down, you're basically saying that. Okay? Getting a little harder, we have the square root of negative 12. So again, it's not real, but 12 breaks down into 4 times 3, and how about I just say negative 1? So there's a product that's equal to 12. We know that the square root of 4, the square root of negative 1, and the square root of 3. This is 2, this is I, and that's square root of 3. So that's how we would write this number now. So that number actually has a definition because of our definition. It's still not real, it's purely imaginary. All right, and then getting back to complex numbers, the square root of negative 1 is I, so we're looking at 5 plus I here. So this number has 5 real parts and 1 imaginary part. We have negative 2 plus, well, the square root of negative 9 we now know we can write as 3i. So we have negative 2 real parts and positive 3 imaginary parts. Last but not least, we have negative 3. The square root of negative 16 is 4i. So that minus sign just is still a minus sign, and the square root of 16 is 4. The square root of a negative is I. And so we have a complex number. So negative 3 real parts and negative 4 imaginary parts. All right, so that's your introduction. Right, we have this new definition that creates some new realities for us, and mathematicians and scientists and engineers can actually mathematically model some unique situations. My last comment on here is, again, you guys might not think it's a big deal, and rightfully so, but I kind of liken this idea to art, right? In our human existence, right, this is what we have in reality, and then what we have is art, which is basically in the imagination of people. And you can imagine our world without art, without music, without poetry, without sculptures, without paintings, right? Our world would be pretty boring. And so we basically take the reality part, human, right? Physically, I am a human being. And in my mind, right, and with my hands and everything else and the vision in my head, I can create art that people can visually see. And so these two things together create our reality and make our world a better place. And that's kind of what complex numbers do for mathematicians and engineers. It combines something real with something imaginary, and together it does some pretty amazing things. All right, so let's go see how we add and subtract and multiply and divide these things.